So now you have these hypotheses. You have your research hypothesis and you have your null hypothesis. All right? Then you have to pick the test. How do we pick the test? We pick the test on the basis of the level of measurement, right? All right, so that's what the whole structure of this course is. I have my levels of measurement for my variable or my variables, and I go to my chart, and I say, hey, I've got an ordinal, and I've got an interval, and it take me to a specific square in the chart, and that tells me what test I can use. I have to pick the significance level, right? So I'm going to need that. In this case, we're always going to use 0.05 in this course. We're always going to use 0.05. Sometimes there's reasons to pick other things. Sometimes you could use 0.1. Sometimes you need to use 0.01, which is tougher. The smaller this gets, the harder it's going to be for you to get to a finding. But by convention, 0.05 is most often used, and so that's all we're going to use in this course. So now we've got our test, we've got our data, and we've got our significance level. So now what we're going to do is calculate. And we do a bunch of calculations, which we're going to show you how to do with a bunch of different statistics as we go through the remainder of the course. And so we calculate out the value of the test statistic. All right, and that's going to give us some kind of number at the end. We're going to get this calculated value of each one of our test statistics. We're going to get that calculated value. So maybe it's 2.1 or it's 10.7 or whatever it is that we calculate out. And then we've got to figure out how that number fits in to that distribution that's associated with the statistic. Is it something that's pretty likely, or is it something that's really unlikely given random chance? If everything is just happening randomly, is that value likely or unlikely? And if it's unlikely enough, we're going to get to come to a conclusion that we found something, okay? We need to compare it to something, though, in order to draw that conclusion. So we have our value that we calculate, and we've got to figure out, based on the distribution of this variable, is it unusual or not? Would that be really unusual to see that? And the way we do that is we have to find the critical value of the statistic, okay? The critical value. And how do we do that? Well, we're going to use our 0.05 level. We're going to have a table for the test that's going to tell us what the critical value is at this particular level of significance. So it's nothing you have to calculate or anything like that. You're just going to look it up in a table. Most of the time, the computer would figure that out for you. But we're doing this course without requiring you to use a computer. So we're going to have a table for you to look it up instead of making the computer calculate it or look it up for you. Okay? So then we'll have a test statistic and we'll have a critical value. The critical value will be the number that we got to beat in order for there to actually be, for us to conclude that there's probably a relationship. Right? You can't say that there is a relationship. You don't want to conclude that. You want to conclude that there probably is a relationship. So we got to beat that value. So we're going to, if we want to see a relationship, we're going to need this test statistic. It's funny how you're teaching statistics and you can't say the word statistics. So this critical value is the value that you've got to beat. If you want to see a relationship, then this calculated value is going to have to be bigger than this critical value. That's what we're going to be looking for when we get all done. So we have our data, we pick our test, we calculate it out, and then we look up the critical value, and we're going to see if the calculated value is bigger. And if it is, we have something. Okay? We can draw a conclusion, right? So then that's the next step. We make a decision about our hypothesis. So we look at it and we say, is this calculated value bigger than the critical value? If it is, then we say we reject the null hypothesis. The null hypothesis is that there's no relationship, and we get to reject that. We reject the null hypothesis and say, hey, I think there's something there, right? That's typically what we want. We usually want to find something when we're doing our research, okay? On the other hand, if the calculated value is lower than the critical value, then we're going to say, hey, We can't reject that null hypothesis. We have to accept the null hypothesis and say, hey, we didn't find anything that was just different than what you'd find by random chance. And so we're done. We didn't find anything. That's the decision that we're making at this point. Okay? If you actually found something, okay, then you've got this very last step, which is to try to get some kind of meaning out of that, okay? All right, a lot of things can be statistically significant, meaning that they didn't happen by random chance, but does that difference really make much of a difference? If I find out that Hispanic people have a 0.05 IQ higher than white people, okay, and I conclude, because I have a really big sample and therefore it's statistically significant, does that really mean anything though? Does that difference in IQ really turn out to have any difference in how people interact with the world or are able to negotiate the world? And the answer would probably be no. Now I just made that up. There's no such relationship. But nevertheless, a lot of times if you have really, really big samples, everything is statistically significant, but that doesn't mean it means something substantively. So you've got to take that last step and think through. And don't just say, hey, there's a relationship between these two things because it was statistically significant. No, there's a relationship, yes, but does it mean anything in real life and how things operate? Maybe not. So you've got to have both of those parts in order to really make a conclusion that means something. Okay? All right. The point of that last one is that you can't just depend on statistics. You've got to think about what you're analyzing and what it really means too. Okay. All right, that's it for this chunk of the course. Next, if you followed all that, next we're actually going to dive in and grab some data and actually do some tests. And that's what we're going to do in the rest of the course, is just take you through the tests that are associated with these different levels of measurement and show you how to do them. You're going to see that it's very straightforward, and we're just going to keep going through these steps over and over again with different kinds of statistics and different kinds of situations. See you next time.